Um, my name is David, and today we're going to talk a bit about, verification of OS artifacts, but without stateful keyrings, and what that means, well, we'll look into now, basically. Here's a little overview, and talk a bit about OS artifacts, what that actually means in this context, what keyrings I refer to when I talk about this, and what underlying unifying concepts are in this entire thing, and show you an example of what we've done so far in this work related to this topic. A little bit about me. I'm a freelance software developer. I have been working on Arch Linux for numerous years now, and I do enjoy writing Rust and Python and do work on infrastructure things when I have time. So when we talk about OS artifacts, in this context at least, we mean something like package files in the context of packaging, or the repository metadata that basically describes what is in a package repository and is usually also signed. But also OS updates in general, more generally speaking, images, OS images, big thing these days, virtual machines, installation media, all of that is usually signed when you download it, so that you can verify that whoever made it available to you didn't tamper with it, basically. When looking into keyrings, or what I refer to as stateful keyrings, the go-to technology, I guess, these days still is OpenPGP. It has been around for many, many years and has gone through a lot of changes over the years as well. Stateful technology in that case is most definitely GNU-PG's GPG, but also Sequoia PGP's SQ, which has its own sort of stateful keyring, or key store format, basically, that is used all throughout everything we use every day, basically. This usually means that we have, per application locations, we have, for instance, a package manager that uses a specific location for its trust store, or the certificates that it trusts to have signed packages, for instance. We have system updaters, such as system sys update, that also basically works under the same premise. We have image creation tools that work on this basis as well, be it for instance, installation media creation and things like that. Generally, you could say that you have these general questions about all of them, like what do we sign? In what role do I sign? Am I like a distributor? Am I a Linux distribution? Am I just some rando that likes to build a package for their own project, basically? Which might actually be also the context. In what context would I place this artifact? Would I put it into a repository, for instance, of a specific name or something like that? Is there a PKI somehow attached to this entire thing? Do I only have one certificate, or do I have an entire chain that I can verify, basically? Good examples, I think, are system sys update, actually. To my knowledge, this is still the case. You have basically two locations in userlib and etc where a keyring is expected if you have a system basically that is updated via system sys update. The process would download these updated payloads depending on its configuration, the checksum file and the OpenPGP signature for that checksum file, and then verify that entire thing, but doing that by running GPG in basically a temporary location, importing the keyring, and then verifying the thing. It's all kind of yuck because of GPG's very stateful approach to everything, basically. You can't really run it without having this keyring directory and everything attached to it. So it's a bit painful. We have a similar example is when using Pacman on Arch Linux, for instance, or derivatives. You have a stateful keyring in etc pacman d GNU-PG. That is the literal GNU-PG keyring directory, basically, that is being used. The Pacman in this case downloads package files or repository metadata and then verifies things using this keyring. It uses GPGME, which under the hood is basically just shelling out to GPG and verifies basically the artifacts with it. As you see, we have like 2 locations already. Per application is very specific. We don't really have any unified view on any of this, unfortunately. There are other technologies, of course, that are being used in the wild, not necessarily always for OS artifacts, although I've seen CMS and PKCS7 being used widely for all sorts of things. I guess Minisign, Signify, etc. are maybe a bit more of an outlier. I'm not entirely sure about Signify in the context of BSD. That's probably quite big. I'm really not following that ecosystem too much, so I can't really judge. And well, SSH signatures are also a thing. Mostly people probably use it for Git, but you can sign anything with it basically and have a detached signature lying around. So yeah, I guess in general you could say we have unifying concepts around all of these, or similarities, I guess, between these technologies when they're being used in this context. And we have, well, digital signatures that are created in one particular role for that particular context, as in I'm creating a package, I sign it for that particular repository. Sometimes you have trust anchor setup, so a PKI. When talking about Arch Linux, we have a few main signing keys that basically each sign a packager key, and you need 3 or more signatures of these main signing keys to basically be a valid packager key. So that's our like mini PKI, so to speak. But other models exist, depending on technology as well. Usually all of these are actually authenticated without necessarily being tied to any type of OAuth provider, so it's kind of differs from Sigstore, for instance, in this regard, I guess. Although I heard Sigstore also has local bundle stuff, but I'm not entirely sure how that really works. But you could definitely say that actually no unifying structure exists among all of these. So they all have kind of similar concepts, but at the same time, we don't really make use of these similarities so far. And that's where the mouthful file hierarchy for the verification of OS artifacts comes in. It's a specification that we've been writing since last year and basically finished on, at least for the initial experimental support for OpenPGP. And yeah, in short, it's basically a directory, a semantic directory for verifiers, and it allows overrides. It's kind of similar to how you kind of structure overrides in systemd context with services, for instance. It's kind of functions similarly. Yeah, here we encode certain things, such as the origin, which is the operating system, the purpose, for instance, the packages, and the context, one particular repository, in this lookup directory for each verifier, basically. Yeah, and on top of that, at least by definition, this allows also trust anchor evaluation, and it's multi-technology. It's not really centered around just serving one particular technology, but it's actually meant to be open enough so that you can use multiple technologies with the same lookup directory. This is roughly how this looks like. For instance, for an OpenPGP example, I think it's a bit short over here. It ends in .openPGP in this case. But what you can see is that yeah, we have this lookup directory, and it's semantically just a semantic hierarchy for a particular operating system, in this case Debian 12, and we're making available a verifier for packages in the default role. It doesn't really specify like what type of or what type of yeah, context it is used in, which means that it's basically usable for any type of package verification. This is just an example, of course. And we encode specifically the technology here as well. So to sum it up, I guess the goals here are really to figure out similarities between technologies, to have something that we can easily adapt to, potentially, and by making available a directory structure that is really just encoding the semantics about what you're using the verifier for, which makes it pretty easy to actually distribute them, because you literally just put them in a directory, and you could zip that and just package it, or put it somewhere. This is pretty stateless for users too. Users can just access that particular verifier. They don't need to deal with some particular keyring format that is proprietary in some way, and it offers you easy override semantics or merging semantics for these verifiers. In total, this is actually really thought of as something to be able to switch very easily between technologies as well. So if you imagine you want to, I don't know, stop doing OpenPGP and do SSH instead, or the other way around, or whatever, you could just do that. You just put verifiers somewhere, and the semantics would just be the same for what you're trying to verify here. To give a very simple example, it's pretty fresh off the press, as they say, from last night. This is now an example of the VOA reference implementation, which we can use to, for instance, here we're cloning the Arch Linux keyring. You see that we have currently no verifiers. We're importing all verifiers from the Arch Linux keyring, from the packagers basically. These are all packager verifiers, so certificates. And we're verifying, for instance, the systemd package now with the sum of all of these verifiers that we have. And it can be as easy as that, and that's what we're trying to do. But there's more work to do, as you can imagine. It's a bit of an undertaking. Well, the OpenPGP technology that I just showed you is just the beginning. It's really like the experimental early stage of it, because we're not dealing with trust anchors at all in that case. We're literally only taking like, oh, there's a bunch of verifiers. We're using those to verify something. There's no additional semantics attached yet. That's something we're working on still. This will entail also some form of configuration file format that we can reuse, that encodes automatically like certain aspects of the verification process that can be also dealt with system-wide, to, for instance, say, I want to use trust anchors in a specific way. I need a specific threshold, for instance, when I have OpenPGP main signing keys, I need 5, and this is basically still up for implementation. But as I mentioned earlier, OpenPGP is basically the only thing that is currently implemented. That is basically for a reason, mostly expertise reasons. We have seen already a proof of concept for CMS PKCS7, which we would love to integrate and further develop. Me personally, I actually lack expertise on that particular field, but I'm hoping to basically shepherd that work into it. That would be really nice. And also to find interested people for the remaining ones that we would like to see implemented, such as Minisign, Signify, SSH. I think the earlier two are probably much easier to actually deal with than SSH, as it has a lot of more complex semantics around like how you can do overrides and block lists and all of that kind of stuff. And yeah, we would also like to break out our test suite. The current test suite is very specific to the VOA reference implementation, but we would like to make it available so that anyone can write an implementation for this and just run against that test suite, so that at least the functionality is shared and the expectations too. So if you're interested, have a look. Here are the slides as well, and, in case you need I don't know. You can also check it later on the video, I guess. I would like to say thanks to Sovereign Tech Agency, who has been basically funding much of this work for the context of the ALPM project. I'd like to thank Heiko Schäfer, who's been quite instrumental in co-writing the specification and also dealing with a lot of the OpenPGP related semantics. There have been lots of reviewers and implementers, thanks to those as well. And yeah, here's a bunch of links as well. The VOA specification has links to the GitHub organization, which is part of the UAPI group, and you can look into the specification there. You can also open tickets, etc., or start discussing other technologies if you're interested. And there's a link to the VOA reference implementation on Crates.io. Other than that, in case you have any questions, I think I'm now done. Thanks.
And besides this standard of specifying things, in your reference implementation, is that actually also doing the verification process, or does it just provide like a lookup that gives you the correct file for the application to verify that by itself, or how do you imagine this will be used?
Yeah. So what we currently have is basically a set of libraries. We have a library for the lookup functionality. We have a library for specifically the OpenPGP backend, which then takes over. So the core library basically just assembles a set of files that it thinks are matching and hands that over to the functionality in the other library, which does the actual verification. And as I mentioned earlier, this is only based on direct OpenPGP certificate verification. It is not based on Web of Trust or anything like that yet, but still to come.
Do we have more questions? Is this expected to be used for the Arch Linux packaging signing, or?
Not really for signing. If so, then for verification purposes. Yeah. The interesting thing is the broad approach is actually, I believe, the power of this entire endeavor. That you can just take that entire hierarchy for some other distribution and verify their packages or anything like that. You don't need that package management system necessarily anymore. You could just verify it the same way with this verifier hierarchy, basically. And for package management, this would be beneficial, especially when looking at GNU-PG kind of drifting further into proprietary standards. So it would be very good to move away from that quite soon, actually. Yeah.
What was your experience working with OpenPGP in Rust? Did you face some immaturity from Rust perspective, or?
It's it's an interesting ecosystem, I would say, because multiple libraries exist. I think it's fair to say that there are really extremely capable and very nice people working in OpenPGP, actually, and I'm super happy with the RPGP implementation currently and working with that, although it is very low level. But people like Heiko Schäfer, for instance, he's been spending quite some time in smoothing over the edges, because it is not easy to work with OpenPGP if that's like your first thing to work on. It's brutal. It's certainly not easy, and has a learning curve, definitely.
Do we have more questions? No? Yes.
Does the specification talk anything about or support using multiple technologies at the same time or during like a transition period?
Yeah, I don't think we've specified that, because this is getting into very complex territory. And the thing is also that I believe it would actually be on the implementer's side, because the specification just says where to put things and what they should look like, basically, and roughly how you should use them, but not necessarily much more about like how you can mix them. And I believe that actually to be something of on the implementer side, because you could always just, if you look at like the VOA command line tool, for instance, you could just say, oh, verify using OpenPGP. Oh, that didn't work. Maybe also try SSH, or you could even implement queries that just try and use anything, any type of verification method, right?
More questions? No? No more questions? 1, 2, 3. Okay, time up. Thank you very much again.
Thanks.